The Sun is the closest star to Earth, and it is the center of our solar system. It is a massive ball of gas, primarily made up of hydrogen and helium, and it generates the energy that keeps all the planets in orbit around it. In this article, we will explore the Sun's description, size, and location in space in detail. The Sun is a yellow dwarf star, and it has a diameter of 1.39 million kilometers, 864,938 miles. It is 109 times bigger than Earth and accounts for 99.86% of the mass of the entire solar system. The Sun is primarily composed of hydrogen, 74.9%, and helium, 23.8%, with other elements making up the remaining 1.3%. It is a nearly perfect sphere, with a slight bulge at the equator due to its rotation. The Sun has three main layers: the core, the radiative zone, and the convective zone. The core is the innermost layer, where nuclear fusion occurs, and it is the source of the Sun's energy. The radiative zone surrounds the core and conducts heat through the outward movement of photons. The convective zone is the outermost layer and is where hot gas rises to the surface, cools down, and falls back into the interior. The Sun's size is massive, and it is the largest object in our solar system. Its diameter is 1.39 million kilometers, 864,938 miles, which is about 109 times the size of Earth's diameter. The Sun's circumference is about 4.4 million kilometers, 2.7 million miles, and it has a volume of about 1.3 million times that of Earth. The Sun is located at the center of the solar system and is approximately 149.6 million kilometers, 93 million miles, away from Earth. It is the nearest star to Earth and is the primary source of energy for all living things on our planet. The Sun is also part of the Milky Way galaxy and is located in one of its spiral arms called the Orion Arm. In conclusion, the Sun is a massive ball of gas, primarily composed of hydrogen and helium, located at the center of our solar system. It is a nearly perfect sphere with a diameter of 1.39 million kilometers, 864,938 miles, and it is 109 times bigger than Earth. The Sun is the primary source of energy for all living things on Earth, and its location in the Milky Way galaxy is in one of its spiral arms called the Orion Arm. Understanding the Sun's description, size, and location in space is crucial for a better understanding of our solar system and the universe. The Sun's formation is believed to have begun about 4.6 billion years ago when a massive cloud of gas and dust in space began to collapse under its own gravity. As the cloud contracted, it began to spin and flatten into a disk. At the center of the disk, the temperature and pressure became so high that nuclear fusion began, leading to the birth of the Sun. The Sun is a massive ball of gas, primarily composed of hydrogen and helium, and it generates energy through the process of nuclear fusion. The core of the Sun is where the nuclear fusion occurs, and it is the hottest and densest part of the Sun. The temperature in the core is about 15 million degrees Celsius, 27 million degrees Fahrenheit, and the pressure is about 340 billion times that of Earth's atmosphere. The intense heat and pressure cause the hydrogen atoms to fuse together, forming helium atoms and releasing massive amounts of energy in the process. The energy generated in the core of the Sun is transported to the outer layers through a process known as radiation. The photons created by the fusion reactions in the core travel outwards and bounce around the radiative zone until they reach the convective zone. In the convective zone, hot gas rises to the surface, cools down, and falls back into the interior, creating a cycle of rising and falling currents of gas. The Sun's magnetic field is also an essential part of its internal structure. It is generated by the motion of charged particles within the Sun, and it is responsible for many of the Sun's dynamic phenomena, such as sunspots, solar flares, and coronal mass ejections. The Sun's magnetic field also plays a crucial role in the formation and evolution of the solar system. In conclusion, the Sun's formation began about 4.6 billion years ago, and it was born from a massive cloud of gas and dust that collapsed under its gravity. The Sun is primarily composed of hydrogen and helium, and it generates energy through nuclear fusion in its core. The Sun's internal structure is also affected by its magnetic field, which is responsible for many of the Sun's dynamic phenomena. Understanding the sun's internal structure and processes is crucial for a better understanding of our solar system and the universe. The sun is the largest and brightest star in the observable universe. The sun has a complex and dynamic magnetic field that generates phenomena such as sunspots, flares, and coronal mass ejections. The temperature at the core of the sun is about 15 million degrees Celsius, 27 million degrees Fahrenheit, and the surface temperature, or photosphere, is about 5,500 degrees Celsius, 9,932 degrees Fahrenheit. The sun's atmosphere, or corona, extends millions of kilometers into space and has a temperature of about 1 million degrees Celsius, 1.8 million degrees Fahrenheit. The sun's surface is covered in granules, which are the tops of convection cells, and is also home to features such as sunspots, prominences, and filaments. The sun has a significant impact on Earth and its environment, from providing warmth and light to affecting the planet's climate and weather patterns. The sun's energy output, known as solar energy, is a crucial driver of the Earth's climate and life on the planet. Solar energy is the energy that is radiated by the sun, and it is the primary source of energy for life on Earth. The sun's energy is responsible for the water cycle, wind patterns, and the growth of plants through photosynthesis. The solar energy that reaches the Earth's surface can be harnessed through various technologies, such as solar panels and solar thermal collectors, to provide electricity, heating, and cooling. Solar activity can also have a significant impact on Earth through the release of energy in the form of solar flares and coronal mass ejections. These events can send high-energy particles and radiation towards Earth, and if they are strong enough, they can disrupt power grids, satellite communications, and other technological systems. The most severe form of solar storms, known as geomagnetic storms, can cause spectacular auroras, but they can also pose a danger to astronauts and aircraft. The sun's activity follows a cycle that lasts approximately 11 years, with periods of increased and decreased activity. The sun's magnetic field plays a crucial role in this cycle, with sunspots and other magnetic activity increasing and decreasing in frequency over the course of the cycle. In conclusion, the sun's impact on Earth is vast and complex, with solar energy playing a crucial role in the planet's climate and weather patterns. Solar flares and other solar activity can also have a significant impact on technology and infrastructure, making the study of the sun's behavior and its potential effects on Earth a crucial area of research. As our dependence on technology and energy continues to grow, understanding the sun's impact on our planet becomes increasingly important. The sun is a complex and dynamic object, and scientists have been studying it for centuries to better understand its behavior and its impact on Earth. Despite this long history of research, there is still much to learn about the sun, and new discoveries are being made all the time. Scientists study the sun using a variety of tools and techniques, including ground-based and space-based observatories. One of the most important tools for studying the sun is the telescope, which can be used to observe the sun at a variety of wavelengths, from visible light to X-rays. Space-based observatories, such as the Solar Dynamics Observatory and the Solar and Heliospheric Observatory, have revolutionized our understanding of the sun by providing detailed and continuous observations of the sun's behavior. In addition to telescopes, scientists also use instruments that can measure the sun's magnetic field, its plasma, and other properties. This data is then used to create computer models that simulate the behavior of the sun, allowing scientists to make predictions about future solar activity and its potential impact on Earth. Solar observatories also play a crucial role in the study of the sun, with many institutions around the world dedicated to observing the sun and sharing their data with the scientific community. These observatories use a variety of instruments, including telescopes and spectrographs, to capture detailed images and data about the sun's behavior. In conclusion, the sun is a complex object that continues to fascinate and challenge scientists. Through a combination of ground-based and space-based observations, as well as computer modeling and other tools, scientists are making new discoveries about the sun all the time. The study of the sun is a crucial area of research, with implications for everything from space weather and climate to our understanding of the universe as a whole. Here are a few interesting facts about the sun. The sun, at approximately 4.6 billion years old, is about halfway through its estimated lifespan. The sun is so large that more than 1 million Earths could fit inside it. The surface temperature of the Sun is about 5,500 degrees Celsius, while the temperature in its core is an astonishing 15 million degrees Celsius. The Sun is not actually on fire, but rather it is a giant nuclear reactor, with hydrogen atoms being fused into helium atoms in its core. The Sun's magnetic field is so strong that it can cause massive solar flares and coronal mass ejections, which can have a significant impact on Earth's technology and infrastructure. The Sun's gravity is so strong that it keeps the planets in our solar system in orbit around it, and it is responsible for shaping the structure of our galaxy. Sunspots, dark patches on the Sun's surface, are caused by variations in the Sun's magnetic field. The Sun's atmosphere, called the corona, is much hotter than its surface, with temperatures reaching up to 2 million degrees Celsius. The Sun rotates on its axis once every 27 days at its equator, but it takes about 34 days for the Sun to complete one rotation at its poles. The Sun's energy output is not constant, but rather it goes through a cycle of approximately 11 years, with periods of high and low activity. The Sun emits a stream of charged particles called the solar wind, which can have a significant impact on Earth's magnetic field and atmosphere. In August 2018, NASA launched the Parker Solar Probe, which will travel closer to the Sun than any spacecraft in history in order to study its atmosphere and magnetic field. The Sun is responsible for all life on Earth, as it provides the energy needed for photosynthesis, which is the process by which plants produce food. The ancient Egyptians worshipped the Sun as a god, and many other cultures have also revered the Sun throughout history. The Sun will eventually run out of fuel and will expand into a red giant, engulfing Mercury and Venus, and possibly even Earth, before eventually collapsing into a white dwarf. In conclusion, the Sun is a fascinating and complex object, and our understanding of it is constantly evolving as scientists make new discoveries and develop new technologies to study it. From its role in the solar system and the universe as a whole, to its impact on our daily lives and the future of our planet, the Sun continues to be a source of wonder and inspiration for people around the world. The Sun is an amazing and awe-inspiring object that has captured the attention and imagination of people throughout history. From its immense size and temperature, to its complex and powerful magnetic field, the Sun is an object of great scientific interest and study. Its impact on our planet, from providing energy for life to the potential for dangerous solar flares and storms, is also an important topic of study. As we continue to explore and learn more about the Sun, we can gain a greater appreciation for its place in the universe and our own existence.